Are you ready for Sunday? It's on factoring polynomials. Okay, so let's see here. We're going to do some factoring polynomials, and we're going to try to make sure that you can hopefully understand this. This can be an interesting lesson, but I try to make sure that I keep it certain patterns because I'm really trying to expose you to this idea of how to factor polynomials of something higher than a quadratic equation. Now, keep in mind, I want y'all to remember also how we factored quadratics. There will be some special cases we'll talk about here, but remember this little bit about plus plus and all that. Okay? So we're going to start off with something easy and talk about the sum and difference of two cubes. So these will be a special formula. You're going to recognize cubes, and there's only going to be two terms, and then you're going to have this formula to follow. So this into your note cards, and making sure you know this in your notes is very, very, very important. Okay, so here's an example. We can see here that what you need to recognize on this, first off, there's two terms. Second off, that each term is a perfect cube. Now, what do I mean by a perfect cube? I mean some number times itself 3 times, that gave you that. And then you would have to recognize what that is. Like in this case, what is the cube root of 8? Well, you'd have to recognize that 8 is 2, and then on the exponents, that's easy. Just divide that exponent by 3, and then you'll figure out how that is. So following the formula, I need to take the cube root first, and those are the numbers that go in the parentheses. Cube root of 125 is 5, and then there's the y. Okay, and I put that in parentheses. Then I take those two terms. I'm going to square the 2x. That would be 4x squared. And there's that bell. And then I'm going to say 5 for the middle term, the one in the middle, because there's going to be 3 terms in the second parentheses. It's multiplied. 2 times 5 is 10, and put the x and y together. And then for the last one, you square the 5. So 5 squared is 25, y squared. Okay. Now, according to this, let me put according to the thingamabobby, notice here how the signs behave. They're basically the same except for a difference of the signs. So, go back to that. That means since it's a plus, there's a plus in the first, there's always going to be a plus on the end of the second parentheses. There's a plus in the first parentheses and then a minus in the second. Okay? When it's a little bit different, you know, you could see something different. Well, and I'll show you that in a second. Please make sure you know your cubes 2 through 10. This is very important to make sure that you would understand this. So like I could easily say 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, and 9 cubed is 729, and 10 cubed is 1,000. You know that your cubes? That would be great. So here's what I'll do. You show me a table of your perfect cubes, 2 cubed through 10 cubed, and I'll add 5 points on the next test. All right, so let's see here. Okay, so what's the cube root of 64? The cube root of 64 is 4, and then again, like I said, take the exponent, divide it by 3. So x to the 6th, the cube root of that is x squared. And then 27, the cube root of that is 3. Then on the next parentheses, I'm going to say 4 squared is 16, and then x squared would be x to the 4th. X squared times x squared is x to the 4th. Notice that 2 plus 4 is 6. Okay? And then 3 times 4 is 12, x squared. Notice how that one repeats. Okay? And then 3 squared is 9. That one should be a plus. And then because there's a minus here in this one, the first parenthesis gets the minus, and the second parenthesis gets another plus. And there you go. That's the sum and difference of two cubes. We'll try to make sure we get plenty of practice with those. Now keep in mind, not every single one of them will always be perfectly factorable. You need to make sure that you've got cubes. 2 and 5 are not perfect cubes. They're just numbers. So I can't do anything with this one, so I would say it's just prime. Okay, so when you can't factor them at all, that's prime. That doesn't mean try to put that for every freaking answer. I'm not going to do that very often. Please, come on. Okay, here's another chart. For any number of terms, you should always look for a greatest common factor. That shows you an example of that. If there's only 2 terms, either you've got a difference of 2 squares, sum of two cubes, or difference of two cubes, which we've gone over these other two examples. This one, it would have to be squared, and we'll talk about those when you'll see them. Perfect square trinomials, general trinomials, 3 terms, that's usually our quadratics. That's ones with the x squares. 4 or more, you have to do grouping. And the book's grouping is very interesting, but I'm going to try to make it fairly simplistic. At least that's my goal. So based on that chart, again, when you see something like this, the first thing you want to be able to do is, first off, see if there's any common factors you can take out, which means, okay, so this is 2 terms, and I don't see like squares or cubes or whatever, but I notice here that like, what's the largest number that can go into 16 and 54, or not the largest number, but a number that can go into both? Well, you should hopefully recognize a 2. And then you notice there's an x in both, so you can take out an x, and when you do that, so you take out a 2 and an x, you're taking out the greatest common factor, you're left with 8x cubed plus 27y cubed. So now, you now have a sum of 2 cubes, and you can further factor that out like this. So, following the formula from before, this cube root of 8x cubed is 2x, the cube root of 27y cubed is 3y. Square it, multiply, and so on and so forth. And that comes up with that. Now, if you don't understand what I just did there to get this to become that, let me know, and I'll go over it. That's what I do in class, you know. I want y'all to be able to ask me questions when you don't understand. So factor by grouping. Here's how I try to understand factor by grouping. When I see 4 terms or more, I like to divide like the first half and the second half apart and factor them separately as one separate problem. Now, for whatever reason, the book kind of like to mix things around. I won't do that. I like to make sure you have it in the order that you need them to be in so that you can group them together. So like here, I'm going to group the first 2, and the last 2 because there's 4 terms, so I'm doing 2 and 2. Now, on the first thing you're doing here is factoring out the greatest common factor. You're doing a GCF. Okay, so you can see here in the first parentheses they both have x's, and you want to take out the most x's they have. So this one has 3, this one has 2. You're going to take out 2, and you would have x squared. That would leave you with an x plus 5 in that parentheses. Now, the way this works with grouping is that this parentheses that you're getting is going to repeat. So that means this one has to be equal to that. So I'm going to go ahead and write x plus 5. Oops, that's not what I meant to do. Okay, so I'm going to write x plus 5. Now, what did I take out of here to get x plus 5? Well, the easy part about that is if you divide these two numbers, which I probably already drew that arrow, 35 divided by 5 will tell you what number goes here. And that's positive 7, because 35 divided by 5 is positive 7. So now I can write down what is my repeating parentheses, and then I put the other 2 together. So x squared, this plus this I put together to make the second parentheses. Now, if you can further factor that's great, but this is just an x squared plus a number, you can't. If it had been x squared minus a number, maybe. Okay, so let's look at another example. Okay, so again, here's 4 terms. I'm going to put 2 and 2 together, like that. I'm going to take out an x squared in the first one, and that will leave me with an x plus 3. I'm going to write x plus 3 again, and then negative 48 divided by 3 is going to give me negative 16. So that tells me that that's what I took out of this one was negative 16. That left me an x plus 3. Put those 2 together, so x plus 3 and then x squared minus 16. Now, here's where you got to be careful. When you see minus for the x squared ones, they can sometimes be further factored. You got to ask yourself, are they a difference of 2 squares? In other words, is there a square root for 16? Yes, there is. So then you could say it's x plus and x minus the square root of 16, which is 4. So you have 3 parentheses that you will get out of that one. So kind of keep careful on that. I mean, if you can at least get to this, you would get like most of the credit there, okay? Okay, now comes the fun ones, as you could say. And you notice here, there's 6 terms. So what I'm going to do is I'm going to say divide them up into 3 groups, or 2 groups of 3. So here's one and here's one. Now what I can take out of that one is an x, because they each have an x. So if I take out an x, I get x squared plus 8x plus 12. Then that means that the second parenthesis should have x squared plus 8x plus 12. So if I divide the 96 by the 12, the negative 96, I would get negative 8. So that means they had to take out a negative 8 on that. So I put these two that are outside together, x minus 8, and then I got the second parentheses of x squared plus 8x plus 12. This comes back to what we did before, factoring, and so I could go, okay, because that's a plus plus, I need a plus plus, x plus, x plus. Factors of 12 that add up to 8 are 6 and 2, and so that's the rest of the parentheses, and there you go. I'm going to make them hopefully that simple. Like I said, the book likes to rearrange them, so you have to figure out what order they're in. And I'm like, I don't understand that. To me, that's just obnoxious. So let's look at one more example, and then we'll be done. So we have x to the fourth here plus 7x cubed plus 10x squared minus 4x squared minus 28x plus, or I'm sorry, minus 40 or whatever it says. Okay, so notice again how I'm separating the first three from the last three, taking out an x squared this time, and so that would give me x squared plus 7x plus 10, and then on the second one I'm going to take out I'm going to write x squared plus 7x plus 10 again, and then negative 40 divided by 10 is negative 4, so now I have x squared minus 4, and then I have x squared plus 7x plus 10. Keep in mind that if you have a square minus a number, it can be, see if that number is has a square root, which square root of 4 is 2, then you split that up and say x plus x minus the square root. So x plus 2, x minus 2. The other one also can be split or factored. So I'm going to say x plus, so plus plus because it's plus plus. And two numbers that multiply to give you 10, add up to 7, are 5 and 2, and there you go. So again, I'm going to try to, I want y'all to build up some confidence in this. It's not like I'm going to try to be tricky about it. Kind of follow the pattern, and hopefully it should be easy. All right, thank you very much, and y'all take care. See y'all when I see y'all.